Good day and hello everyone. How are you guys doing in this time of year? I hope all of our audience are fine and in top condition. We are Group K20 for final year project 2022/2023. Our research consists of ore waste and synthetic wastewater. Our title is Phosphorus Removal from Aqueous Solution using different mass of ore waste adsorbent from Johor mine. Our group has made short form for this title called PRO. I and Wazif Hilmi bin Ahmad Nizam is one of the member of this project, followed by Muhammad Habil Izzuddin bin Nur Hisham and also Nur Audrizeti binti Husaimi. The responsible SV for this project is Dr. Nurul Huday binti Abdullah. Now, I will go through the list of content of this slide. First, we have the introduction, and then problem statement. After that is the objective, research methodology, expected result, commercialization, social benefits, conclusion, acknowledgement, copyright, and lastly, the reference. Next, I will go through the introduction part of this slide. Phosphorus pollution in domestic wastewater has been a big problem for cities and also small villages. This problem can be tracked from household and the city industry waste. The waste that were thrown out can cause eutrophication process to occur in the river, causing the COD or the chemical oxygen demand to increase. Eutrophication will lead to decreasing of aquatic life, and the excessive use of fertilizer in agriculture also one of the cause for the eutrophication process to occur, because fertilizer will give nutrient to the water, causing algae to grow, thus increasing the BOD of the river water, which is biochemical oxygen demand.
Thank you, Wazif. Okay, now I'm Zeti and I would like to share the problem statement for this research. For starter, mining waste is utilized to make cement aggregate and asphalt aggregate. When we use this material, we will have the opportunity to reduce waste and pollution. It may assist our economy indirectly. Number 2, as you are aware, high phosphorus level in water can cause eutrophication. Eutrophication is the growth of undesirable aquatic vegetation. This condition can cause various issues, including fish not getting enough oxygen, leading to the death of various aquatic species.
The objective of our study is to first to observe phosphorus removal efficiency in water using ore waste, and also to analyze the adsorption capacity using the isotherm model. Second is to analyze and to predict the contour of the removal efficiency and the mass of adsorbent under different initial concentration of the phosphorus aqueous solution. And lastly, to verify the theoretical and the batch experiment data using the kinetic isotherm modeling studies that we have done.
For this section, there are 5 parts that will be explained about the methods and so on that will be used in our project, which are preparation of adsorbent, preparation of aqueous solution, batch test experiment, physical chemical characteristic properties, and parameter analysis. There are 3 steps that need to be carried out in the preparation of adsorbent of the ore waste. Firstly, the drying process, in which we have to put the ore waste into the oven with a temperature of 30 Celsius for 3 days. After that, the ore waste must be sieved in a sieve size ranging from 2.36 mm to 18 mm. Lastly, the ore waste needs to be weighed using analytical balance for 5 different loads, which are 2 gram, 4 gram, 6 gram, 8 gram, and 10 gram, and fill it in a small pack for each of it. The preparation of aqueous solution start by weighing the potassium dihydrogen phosphate, or known as KH2PO4, which is 0.1433 gram on the weighing board using analytical balance. After that, the weighing board is rinsed using the ionized water and water dispenser into the conical flask. The conical flask is then filled with the ionized water until it reaches the intended level 1 liter. Now it is 100 ppm concentration. we need to dilute the solution until it reaches 10 ppm using the formula of C1 V1 equals to C2 V2. C refers to the concentration of the solution, while V is the volume of the solution. The concentration of the solution is checked constantly using DR6000 to make sure the concentration of the solution is in range. Lastly, the finished aqueous solution is placed in the refrigerator. Next, I would like to continue the batch test experiment. Firstly, separate the adsorbent into 5 different weights, which are 2 gram, 4 gram, 6 gram, 8 gram, and 10 gram. Then, in 100 ml conical flask, 100 ml of 5 mg per liter of KH2PO4 solution is combined with the adsorbent separately. The samples are agitated at 170 rpm on an orbital shaker for 6 days. Then, the samples are extracted to the centrifuge tube, separately followed by the mass of the adsorbent. The ore fragment must separate from the centrifuge tube. After that, we filtered the adsorbent solution using the filter set and the vacuum pump. Lastly, we analyzed the solution using the DR6000 UV-VIS spectrophotometer.
Physical chemical characteristic properties of this absorbent can be identified in these 4 ways. Firstly, SEM. For your information, SEM can perform an analysis at high magnification and high resolution image. Number 2 are EDXRF. EDXRF was designed to analyze the group of elements simultaneously, while number 3 are FTIR. By using this machine, we can identify whether the material is organic or polymer. And lastly, number 4 is XRD. XRD consolidation of tool and data that provides extended visibility, analysis, and response across endpoints.
Next, I would like to continue with the parameter analysis of this study. For this study, we use the pseudo first order and second order model to study the absorption of the ore waste. These include the ideal parameter, including the duration and adsorbent dose of the solution. Finding appropriate model that may be utilized for certain objectives require analyzing and adsorption equilibrium data by matching them into several isothermal models. For the isothermal model that we choose the Langmuir and the Friedrich model because these models are the most relevant for our studies that we are conducting. The important contour of this study is the final concentration of the solution and the initial concentration of the solution.
It is expected that the experiment will prove that the ore waste that has been collected from the Johor site is an effective adsorbent for phosphorus removal. Phosphorus will be removed from the aqueous solution more quickly with a higher dose of adsorbent.
Coming up next is the commercialization potential. The commercialization potential for this study is that it can be commercialized for engineering and environmental water treatment. Furthermore, this will benefit the property industry as people now choose to live near natural areas. Besides that, this study can also be a chemical industry as more research is done on this material.
Next, I will go into the social benefit of this study. First of all, we can improve the overall quality of the water. This will lead to improve the quality of the food that produced and the quality of the livestock significantly. And then, less pollution of the wastewater can benefit the marine ecosystem so that the fishing industry can thrive. After that, water-based recreation has the opportunity to thrive at the national level. Lastly, a rise of the property values because of the better water resource that were distributed and lack of water pollution related deterioration.
In conclusion, the ore waste is expected to be effective in removing phosphorus. The higher the amount of the adsorbent, the higher the removal efficiency rate. Lastly, we encourage a future clean water source acquisition strategy that is ecologically friendly to the society to create a better environmental. This research was supported by the Ministry of Higher Education through Fundamental Research Grant Scheme. We would also like to thank the Neo Environment Technology Center for Diploma Studies, Research Management Center, University Tun Hussein on Malaysia, and also our beloved supervisor for this FYP, which is Dr. Nurul Hudai, for the support.
This research copyright will be registered. To write this paper, we have reviewed 50 journals, and these are 5 of them. That's all from us, and we hope you enjoy the presentation and gain some knowledge that can be used in the future. Thank you. Bye.